For today's lesson, our focus standard comes from Grade 8, Expressions and Equations, Standard C, Analyze and Solve Linear Equations. Our topic continues to be from Simplifying and Solving Equations, and today's lesson is on steps to simplify algebraic expressions with algebra tiles. Our essential question for today is, how do we use the distributive property and combining like terms to simplify algebraic expressions? Please take a moment, pausing the video if you need to set up your header, your question column, and your note column, and resume the video when you're ready to begin. So today's video is an effort to show with algebra tiles the steps to solve algebraic equations. So we're going to use some traditional terminology as well as looking at algebra tiles as a visual model to see what that means. And we've talked a little bit already about zero pairs, but when we talk about zero pairs, what we're talking about are equal opposites. So a positive and negative x are equal and opposite, so when they are combined they make 0. The same with negative 12 and positive 12, equal opposites, so when combined they make 0. And our final example, y squared and negative y squared. So you start to see how one term will always be negative while the other is positive, yet they have the same absolute value. And so there are two basic steps that we follow when trying to simplify algebraic expressions. And those two steps are that first we want to get all the tiles into the positive region of the mat. So that really only applies when we're using algebra tiles. And what that involves with algebra tiles is flipping them from usually the negative lower region into the positive region. And you'll notice that the tiles change sign. So it goes from being a positive tile down here. When we flip it up over that dotted line into the positive region, it becomes a negative. What this is an attempt to illustrate is the distributive property. So our first step is to use the distributive property or to get all the tiles into the positive region of the mat. And then our second step is to combine like terms and remove all zero pairs. In this example, they're showing a zero pair in the negative region. Usually all of our tiles, by the time we get to this step, will be up here in the positive region, but you can see that they're equal and opposite, and so they would combine to make 0, and they could be removed. So those are the two basic steps, and we're going to use those two basic steps to go through two examples today. And we're going to focus primarily on what it looks like on the algebra mat, and then when we get to class, we'll combine that with starting to put in the traditional steps for what does that look like if we're not using algebra tiles. Let's go ahead and take a look at our first example. So here's example 1. We have 3x is the expression plus 2 minus the quantity 2x minus 3. Now we've done a little bit of work, or we're about to start a little bit of work where we're still learning to set this up. And so here I've just written it again. So we want to say, okay, everything that's up here, not in parentheses, is going to be put into the positive region. So I need to draw in 3 x tiles that are all positive and 2 positive unit tiles. As soon as I see this negative sign outside of parentheses, it's telling me to go into the lower region, this negative region, and in that region to put 2 x tiles, positive, and 3 negative unit tiles. So go ahead and attempt to draw that in, and then pausing the video if you need to, and then resume the video to see how our work compares. So in setting this up, here's what I'd expect to see. There's a few extra arrows and things on that. You can disregard that for now. But as we mentioned, in this positive region, we have the 3 x tiles and the 2 positive unit tiles. And then as soon as we see this negative outside of parentheses, we go into the lower region and we put in 2 x tiles and negative 3 unit tiles. I've included these large parentheses to show that it's because of this factor here that I included this lower region. That's where that comes from. And here we just restated the algebraic sentence. What these extra arrows are starting to show is our next step. So if you remember from up above, our goals are to use the distributive property or to flip everything into the positive region. So they're showing that we're going to take these two x terms, and we're going to take these 3 unit tiles, and we're going to flip them over this dotted line into the positive region. So remember, anytime we cross this dotted line, our tiles are going to flip over to the other sign. So here's what's going to happen. And go ahead, if you don't want a spoiler alert, pause the video here and see if you can draw in what you think it's going to look like. Alright, so here's what that would look like. We still have the 3 x tiles and the 2 positive unit tiles, but now we've flipped these 2 up. So now they're negative x tiles. And we've taken these 3 unit tiles that were negative and we've flipped them up so they became positive. So we've accomplished our first step, which is to get everything into the positive region. Really what we're doing is using the distributive property, and I'll demonstrate that in class. So can you take a guess at what they're trying to show here, where they've circled 2 positive x tiles and 2 negative x tiles? If you guess that they are removing 0 pairs, you'd be absolutely right. These 2 x tiles that are positive are going to cancel out or make 0 with these 2 negative x tiles. So we can take all of those and remove them. So these arrows are showing what's happening as we go through this process. So on this third and final mat, let's go ahead and draw in what do we have once those 0 pairs are removed. You should have only 1 x tile remaining and 5 unit tiles. This is now as simplified as we can get it. So I'm going to backtrack a moment here and go back to here. So once we flipped everything up, or when we first started, this was the expression we had. Then when we flipped everything up into the positive region, here's the expression we have for this middle mat. We have 3 x tiles and the 2 positive unit tiles. We still have that. But now when we flipped those tiles up, we now have 2 negative x tiles and 3 more positive tiles. Then for our third and final mat, this 0 pairs were removed, and what we're left with when we're completely simplified is x plus 5. So that's our first example. Take a moment to make sure that that is completely copied into your math journal, into your set of notes, and then we're going to go ahead and do one more. So here's our second example. First thing I want you to do is write it down and then see if you can draw that into our mat. And again, I've just rewritten it here. So we have 1 minus the quantity 2y minus 3 plus a y minus 2. So take a moment to think about what's that going to look like on tiles on our algebra mats here. And let's see if we agree. So we're going to have the 1 positive unit tile, and then again I've used these parentheses because now we have this negative outside of parentheses, so we're going to go into the lower region and put 2 positive y tiles and 3 negative tiles. And we're going to close those parentheses, so that's that factor right there. And then we also need to include in the positive region a positive y and 2 negatives. So we've set up our algebra mat to match the expression that we were given. And now we're going to do that first step, and we're going to use the distributive property, or trying to get all the tiles that are from the lower region, we're going to flip them into the positive region. So it would look like this. We still have the positive unit tile, the positive y tile, these 2 negative tiles. But then these 2 positive y's that were in the lower region flipped up to be 2 negative y's in the top region, and these 3 negative unit tiles flipped up to be 3 positives in the positive region. So here's our expression for that middle mat. We have the 1 tile, but now we have negative 2y plus 3 positives plus the y and minus the 2 negative unit tiles. Notice how they've started to circle things that are going to make 0 pairs. A positive and negative y tile will make a 0 pair, and 2 negative unit tiles with 2 positive unit tiles will also make a 0 pair. So they've circled that, and they're drawing these arrows to say I'm going to pull those tiles off the mat. So on this third and final drawing, what do we have once we've flipped everything into the positive region and removed all the 0 pairs? Let's take a look. Well, we should have 2 unit tiles left and only 1 negative y tile. So once this has been fully simplified, all we're left with is negative y plus 2. So that's going to conclude our video for today on how to simplify the steps to simplify algebraic expressions using algebra tiles. And please make sure that your notes are complete and you're ready to discuss and practice more in class.